Hello students, subscribers, and viewers. Here are lecture and sample problem videos on strat trigonometry, statics and trigonometry combined, because in order to excel in statics, you should have good background in trigonometry. So this is about solutions to triangles, right triangles, and on the next one, oblique triangles. For this video, we just focus on solutions to right triangles, but the solutions to oblique triangles, the principles will also be presented here. So these are the principles and formulas. We have 6 ratios for the right triangle, SOHCAHTOA to abbreviate. So this is the right triangle, that's 90 degrees, and this is the angle theta. The other angle is the complement of theta, cot theta, or 90 degrees minus theta. The parts of this triangle are opposite to theta is denoted side A here, adjacent to theta is B, and the hypotenuse, the longest side, is equal to the diameter of the circumscribing circle as shown, and it is denoted by C. So that's the opposite, that's adjacent side. So sine theta is also cosine of the complement of theta, and it is equal to opposite, so it is A over the hypotenuse, which is C. So again, sine of theta is opposite over hypotenuse, and it is also the cosine of this angle, and this angle is the complement of theta, so adjacent of this complement of theta is A over C. Then cosine of theta is also the sine of the complement of theta, in this case adjacent side B over C. Then tangent of theta is opposite over adjacent side. The tangent of theta is also the cotangent of the complement, so A over B. So tangent theta is opposite over adjacent A over B, and it is also the cotangent of complement of theta, which is adjacent sides oppositely over opposite, so A over B. So these three basic part of the 6 equal ratios would be the guide for remembering SOHCAHTOA. Then the reciprocal of sine theta is cosecant theta. So this is the Pythagoras theorem for this right triangle, which is important to the solutions of right triangle. The sum of the squares of the perpendicular legs is equal to the square of the hypotenuse. So that's Pythagoras theorem. So cosecant theta, the reciprocal of sine theta, and it is also secant of complement of theta. So it is equal to C over A. So cosecant is just the reciprocal of sine. Cosecant of theta, reciprocal of sine theta. The reciprocal of cosine theta is secant theta, and secant theta is also the cosecant of complement of theta, and that is C over B. Finally, the reciprocal of tangent is cotangent theta. It is adjacent over opposite, so it is also the tangent of the complement of theta, which is B over A. So just familiar with this SOHCAHTOA, easy to remember, Pythagoras theorem, and remember the reciprocal of sine theta, which is cosecant theta, reciprocal of cosine, which is secant theta, reciprocal of tangent, which is cotangent of theta. So then we have the law of sines applicable to oblique triangles. These are the oblique triangles. We have an obtuse triangle in this case because one of the angles is greater than 90 degrees. So that is A over sine of the angle opposite it equals B over sine of angle B, and it is equal to C over sine angle C, and that ratio is equal to the diameter of the circumscribing circle 2R. For the derivation, you just look at my the playlist in my YouTube channel on maybe first part of statics. You can find the derivation there about the law of sines. Then for the law of cosines also, the derivation is also in the first part of statics, statics 0 or statics 1, or the video on review of trigonometry in statics. So for the law of cosines, so this is law of sines. Any side as to sine of the angle opposite it equals the other side of the triangle as to sine of the angle opposite it equals the third side as to the sine of the angle opposite it, and that ratio is constant equal to the diameter of the circumscribing circle. Then sine theta is equal to sine of 180 degrees minus theta. Also remember this, that the sine of the angle and the sine of its supplement is the same, and that makes the ambiguous case for this law of sines, especially when you solve for an angle and that angle you are unaware that that angle is obtuse. You might just rely the results of your calculator, which will always give us an acute angle. If it is an obtuse angle, you can still use the law of sines as long as you are aware, and it should be 180 degrees minus the answer displayed in your calculator if you're aware that the angle that you're solving is obtuse. So that's it. And for the law of cosines, this is an absolute formula law. There's no ambiguous case. So just remember one, the pattern can be written. So the law of cosine states that any side square is equal to the sum of the squares of the other sides of the triangle minus twice the product of the other two sides times the cosine of the angle opposite the side that is squared in the left side. So that is, so we have law of cosines here. A square equals B square plus C square minus 2BC cosine of angle A. Therefore, B square equals A square plus C square minus 2AC cosine of angle B. Opposite to side B is angle B. Then C square equals A square plus B square minus 2AB cosine of angle C. And of course, we have in any triangle, the sum of the lengths of the shorter sides is always greater than the longest side. So always remember this situation. Then the shortest side of the triangle is opposite the smallest angle. The longest side is opposite the biggest interior angle of a triangle. So that's the principle and concept. So solve the right triangle shown below. So for part I, we have A, side A is 7, B is 24. Then another case, A is 15, C is 17. Another case, C is 13 and angle A is 22.62 degrees. And the last case, A is 36.75, C is 32.64, where C is always the hypotenuse in a right triangle here. That's our guide. Then for part 2I, B is 4, C is 5, A is square root of 2, C is 3. Then we have another case, B is 40.35 degrees, angle B then side C is 15.48. Then another case A is side A is 12.22 units and A is 22 degrees 48 minutes. So for part 1I1, A is 7, B is 24. So by Pythagoras theorem, we solve for C first. So that's the guide triangle. This is the other right triangle. So for 1I.1, which has A, side A is 7 and B is 24, we solve for C first by Pythagoras theorem. C is square root of 7 square plus 24 square. So C is 25. Then for the other values, we just involve A and B always because those are the given. So for angle A, tangent of angle A is A over B. So tangent angle A is A over B, and A is 7, B is 24. So from there, A is inverse tangent of 7 over 24, and that is equal to 16.26 degrees. For the other angle, we know that the sum is 90 degrees. Therefore, angle B is 90 degrees minus angle A. And also, the other way is we have tangent of B, tangent of angle B equals side B over A, opposite over adjacent, opposite to angle B, adjacent to angle B. So solving for angle B, it is 73.74 degrees. Then for the second situation, we have A is 15, C is 17. So B is square root of 17 square minus 15 square. That's for the other way. So again, for part 1I.2, so this time given A and C. So to solve for B by Pythagoras theorem, it is square root of C square, square root of 17 square minus 15 square. So B is 8. Then since it is A and C are, since the given elements are sides A and C, so we define by solving angle A as sine of angle A opposite A over hypotenuse C. So opposite 15 over hypotenuse 17. So angle A is inverse sine of 15, quantity 15 over 17, and that is 61.93 degrees. For angle B, it is cosine of angle B equals A over C. That's A over C also. 15 over 17. So B is 28.07 degrees. So notice that angle B is 90 degrees minus angle A, or the sum of angles A and B is 90 degrees. We proceed to part 1.I.3. This time given C and side C and angle A. So sine of angle A equals A over 13, A over C. Sine of 22.62 degrees equals A over C, and C is 13. Solving for A, it is 13 sine 22.62, and it is 5 units. Then to solve for angle B, we use cosine of 22.62. So angle B also is equal to 90 degrees minus 22.62. So angle B is 67.38 degrees. Then cosine of A, 22.62 degrees equals adjacent to A, which is B, over hypotenuse C, 13. B is 13 cosine 22.62 degrees, so B is 12. Then I dot 1 dot I dot 4, A is 36.75 and C is 32.64. Notice that A is greater than C. So it is C that is longest for this triangle. Since C is not the longest, A is longest. So you notice that if you solve this problem, your calculator will always display math error. So that means there's no solution to this problem because of the fact that A is greater than C or C is less than any other side. So because C is less than A, it should be hypotenuse C greater than A. So there's no solution to 1.I.4. Then for 1.2I.1, B is 4, C is 5. So to solve for A, square root of C squared minus 4 squared, and that is equal to 3 units. Then to involve B and C, we use cosine of angle A equals B over C. So B is 4, C is 5. So angle A therefore is 36.87 degrees. Then to solve for B, it's either 90 degrees minus A, or we use cosine of angle B equals, or sine of angle B equals B, which is given over C, which is 5. So sine of angle B is equal to opposite B, which is 4, over hypotenuse C, which is 5. Because B is 4, C is 5. So angle B is 53.13 degrees. Notice that if we add A and B, the sum is 90 degrees. We proceed to 1.32I.2. And this time A is given square root of 2, C is 3. So B is square root of 3 squared minus square root of 2 quantity square. And that is square root of 9 minus 4, so square root of 5. 9 minus 2, so square root of 7 units. Then to solve for angle A, then we use sine of angle A equals side A square root of 2 over C3. So angle A inverse sine of quantity square root of 2 over 3, and it is 28.13 degrees. Then we use cosine of angle B equals A over C, and A is square root of 2, C is 3. So B is 61.7 degrees. If you add A and B, it should be 90 degrees. Then we proceed to 1.2I.3. This time angle B is 40.35 degrees. Side C is 15.48 degrees. So sine of 40.35 degrees equals A over C, or cosine of 40.35 degrees equals, because B is given, so cosine of 40.35 equals adjacent side A over hypotenuse C, 15.48 is. So solving for A is 15.48 cosine 40.35 degrees, and that is 11.8 units. Then for side B, it is sine of 40.35 equals side B over C. So B is C, 15.48 sine of 40.35 degrees, and that is 10.02. Also notice that if you get the square root of 11.8 square and 10.02 square, it should be 15.48. Then A, B, and angle B, angle A. For angle A, we use 90 degrees minus angle A. So 90 degrees minus 40.35 degrees. So angle A is 49.65 degrees. Then 1.2I.4, A, side A is 12.22, angle A is 22 degrees 48 minutes. So tangent of 22 degrees 48 minutes equals opposite, which is A, which is 12.22 over hypotenuse C. This is tangent, so opposite over adjacent B. So 12.22 over B. Therefore, B is 12.22 divided by tangent 22 degrees 48. So B is 29.07 units. To solve for A, we use sine of 22.48 degrees is equal to opposite side A, 12.22 over C, known. So C is 12.22 over sine 22 degrees 48 minutes, and that is 31.53 units. And finally, we have angle B. Angle B is simply 90 degrees minus angle A, 22 degrees 48. So angle B is 67 degrees 12 minutes. So that's it for this video. It becomes lengthy. So I hope that you were able to understand, follow the explanations and the solutions.